Okay, now after we calculate the all frequency FH in and FH out, so we can sketch the asymptote using that frequency. So we use the same formula as we have done for the low frequency response. So this is the formula: AV high equal to negative 20 log F divided by F2. So for the F2 is actually for FH in or FH out. And this F is frequency that we have set, okay, to get 2 points in the graph. Okay, this 2 point is used to draw the straight line. Okay, so for the FH in, so we get now we divide this one. The frequency I set 1 and 10. Why 1 and 10? Okay, this is because the frequency now is 0.279. Okay, we get frequency is 27789 kilohertz. Okay, 27789 kilohertz. So it equal to megahertz is 0.279 megahertz. Okay. Okay, now why I change to megahertz? Okay, it make you it is better if you, because the largest value now is in megahertz, okay, which is 2.73 megahertz. So our scale now in the semi-log graph, for the log scale, so it will the maximum value is in megahertz. Okay, so I set all frequency now is in megahertz. So it means that now 1 is 1 megahertz and this 10 is 10 megahertz. Same also here, 10 megahertz and 100 megahertz. So when I read here, the number for the frequency, the value for the FH in is 0.279, is actually from this one, 277.89 kilohertz. Okay, then when you calculate the log of this frequency, so do not include the megahertz or 10 power of 6. Okay, you just remove this, okay, and just divide the frequency. For example, 1 divide 1 with the 0.279, and then you log this value and then multiply with negative 20. Okay, same goes here, 2.73, not 273 times 10 power of 6, just remove this one, so it become 10 divided by 2.73. Okay, and you will get this answer for this one. So this is the gain for each frequency that we have set. Okay, now you see the difference between the range for this one. For the first FH in is from 1 to 10, because of the frequency here is from 0.279, and the range for the FH out is 10 to 100, because of this value is from 2.73. For example, here I have, this is the 100 and this is the 10. Okay, the scale is from 10, 100, means that the FH out now, 2.73 is somewhere here. Okay, 2.73. So it will take 2 point from here, from 10 and from 100 Hertz. Okay, so it means that I will get at 10 I will get negative negative 11.28, and at 100 negative 31.28. so this is the actual frequency, is 2.73 megahertz. Here is in AV, in dB. Okay, this is dB and this is dB. Now this is a frequency. Okay, now I plot the points. Okay, so for the first one, the frequency 0.279 megahertz or 279 kilohertz. Okay, this one I plot at 1, so I get here is negative 13, if I'm not mistaken. And then for the second point is here. Once you get these 2 points, and then you can draw the straight line here. Okay, now we go to the second frequency. So plot the first point here, and then the second point is here. So just draw the straight line, and you get okay, you get this frequency. You see, at this point, this is the real frequency is here. Okay, this value.